So I got the turbine here, and I'm ready to hook up to the cold steam system. Okay, so we are about to start our testing here. You can see our pressure it's really foggy, but it's within the 0 to 1 psi range right there. Here's our vacuum gauge. I have this valve turned off right here. It comes in from the boiler right here, and this valve stops it until I'm ready to turn on the turbine. So these are our pressure sensors right here. You can see pressure 1 and temperature 2. And then down here you can see pressure 2, temperature 3. And we have the sensor equipment plugged in, all connected. Here's our RPM sensor right here, and that will show our RPM. And then coils are wired in series. That comes down here to the bridge rectifier. Bridge rectifier turns it into DC and will run these lights with DC. This is our current sensor, and this is our voltage sensor probes right here. And that goes to our brain box right there. Okay, now I'm recording.
Recording in progress.
Go ahead.
Setting the frequency, hertz.
Wow.
1,000 watts, or 1,000 hertz. Shit. Something came loose. Shit.
Recording in progress.
I'm just gonna leave it right here for a while. It's going 1,000 hertz.
But we are generating constant about 400 watts, no more of it from that.
Sounded like I broke something, huh?
Yeah,
I think I did. I broke a disc or something.
damn.
It's still at 1,000 hertz.
Yeah, because now it doesn't generate more. Four hundred and 62. -92 degrees Celsius is very hot, and also the pressure.
Wow, the speed is staying very stable right now. It's burning my wood too. Whoa.
700 we got there a peak. I don't know what
The
jumped.
lights seem to be getting brighter.
400, 600.
Well, I think my turbine's broken. But it's still going 60,000 right now.
Yeah.
I think a disc broke or something because it just went boom.
Yeah, I heard that.
So I just started it back up.
But yeah, basically a stable load will be at 400 watts, mostly
Yeah.
the average that we're getting with the turbine broke.
Oh, broken turbine's doing pretty good, huh?
Yeah, 400 all the time, that range.
So I literally have a water battery right now.
Yeah,
So cool. Wow.
94 degrees, it's getting hot on the inlet.
You know what I think happened? One of the discs maybe went into the exhaust.
Yeah,
I'll have to take it apart to see for sure.
you're gonna leave it running until the steam is gone, huh?
My phone ran out of space. Yeah, I think my epoxy. Oh, sounds like it's gonna go. Wow, it jumped up 7,000 RPM, or it went to 1,700 hertz.
Yeah,
I
here
took the load off for a second.
I'm telling you, we need like a switching load device that allow to have bigger peaks on power. Now, when you made it, we had like almost 500. That's a lot.
Well, it went from 1,000 hertz to 1,700 hertz in 1 second, in less than a second.
Yeah, doesn't seem like true. It's like 100,000 RPMs.
That's 102,000 RPM.
Yeah.
See, that's where I wanted to run it at, you know?
Mm-hmm. That's it. 600, you got in that peak where you disconnected the load.
Yeah.
Yeah, 410. Make it again. Disconnect the load and connect it back again. Let's see what happens.
Okay, 1 second. I want to get it on camera. So we've been recording and my camera ran out of space. And so I want to show. Okay. Wow. Whoa. Okay. I drew like a 2-inch arc, or like a half-inch arc. Yeah. I think I'm gonna shut it down now before it explodes. God. It's probably my epoxy came apart because of the higher temperature. I just need better materials, I think. Yeah. Yep, I think that's what we need. Well, so I got all the screws out, and this part here is actually glued on. So I'm going to break that off with a hammer and unscrew this, and then I'll try and separate this thing. So I just opened the exhaust. Here, nothing's in the exhaust. Got the bottom off. The end cap off there. The bearings look like they're going to be okay. Okay, so here's the moment of truth. Bearings feels really nice, really smooth. So the bearing's okay. Stainless steel too. Well, the rotor is perfectly fine. So, wow.
Look at all that black stuff on the side.
Really, yeah, the rotor was just definitely hitting the side there. Melted a little bit of stuff. I actually think the turbine might be okay. Okay, stop. So the rotor looks pretty good. Even though it crashed at 60,000 RPM, the only damage I see on it is right there. And that's pretty amazing. So it definitely burned a hole, or it burned a bunch. The carbon fiber burned a bunch of the plastic, or burned the plastic pretty bad. So I think the issue was the heat caused the turbine to, or the Lexan to warp a little bit, and under vacuum, it decreased the spacing between the discs and the sidewalls, and then it just ground itself on the side there. But wow, I'm surprised. Carbon fiber is pretty amazing stuff. So I have a new theory about this. I noticed this chip on the magnet, which doesn't make sense because if the magnet was going to break from centrifugal force, you'd think the whole thing would just go. So I think that when I was installing the magnet, I smacked it on the side here, and it was actually chipped on the end, but the chip stayed in place because the thin layer over the magnet, there's a thin layer, I think it's nickel, over the magnet, kept the piece in place, and it didn't shoot off until I got to really high RPM. So I think that's what actually failed, which is actually really cool that maybe that's all that failed in this thing. And maybe when it flew off because of the guard, so I'm guessing when that piece came off, it was stuck in there, in between the magnet and this part, the covering, and it just went until the side of the rotor crashed in, until the rotor here crashed into the Lexan there and caused all that burning. So, not 100% sure, but I think that's the case.